Hello, everybody. So here are the test solutions for our first exam. The instructions here, test is timed as usual. You have 60 minutes, which is about 10 minutes more than you would have if you were in class. And the test is 12 questions long. Absolutely critical that you show work. And of course, don't use Desmos or your notes or any help from an app or anything. You can use a calculator if you'd like, but good luck. So, and it's all the questions were scrambled. So the order I get is not going to be your order. My first question was a solving question. So this is for learning target 5, solving. 5 or 4, I can't remember, but solving. So we have all the information we need here. We just need to interpret this graph effectively. F of x is the absolute value function, so that's the green one. And g of x is the radical function. And it's asking when is f of x less than or equal to g of x? So in other words, what are the x values that make the green function underneath the red function? And I'm sure you can kind of put your finger on it. Like this section right here, the green section is definitely underneath the red section. In other words, the y values are less than g's y values. And then also over here on this part of the graph, the y values on the green function are less than the y values in the red function. So there are two intervals, this interval on the left and this interval on the right. The most common incorrect answer I saw was this. So negative infinity to negative 0.973, always the x values, and then skipping over the x values that produce these y values, and then picking up again at this x value, 0.522, and going off forever. This is very, very close to correct, but negative infinity is not accurate because the radical function doesn't have a domain that goes to negative infinity. The radical function begins at -4. So the correct answer was really everything from -4 to negative 0.973, and then 0.522 to infinity. Another problem that was solving and odd or even, that was 1/3 of your grade. There were 3 grades. This one was for solving, again, solving. So here's the function f of x, and we want to find the x values that make the absolute value of this equal to 1. Well, just by looking at it, it looks like 0 when x is 0 and when x is 4. That's 2 of my answers for sure, because when x is 0, the result is 1, and when x is 4, the result is 1. But there are 2 more because we need to take the absolute value of this. And if you take the absolute value of all of these y values, then the positive y values stay the same. All these y values above 0 are going to stay the same because the absolute value of +4 is still +4. But these y values, these are negative. So when I take the absolute value of a negative, it becomes positive. So for instance, this y value is -2, and if I take that absolute value, it will become +2. And this y value is -1. And if I take that absolute value, it becomes +1. And that's what we're trying to solve. So x equals 6 is also a solution. Because when x equals 6, the original function produces -1, but the absolute value of the function will make that -1 a +1. And same thing for x equaling -2. If x equals -2, on the original function, the y value is -1, but when we take the absolute value, that -1 becomes +1. So there were 4 correct answers that you needed: -2, 0, 4, and 6. And I have a Desmos queued up here. So this is the function that was on the test. And in Desmos, it's pretty cool. Like you can label f of x. And here, this next graph is the absolute value of f of x. So if I graph that, watch what happens. The positive y values stay the same, but the negative y values become positive. So they become mirrored reflections over the x-axis. So this blue crooked graph is the absolute value of f of x. That's ideally what you should have in your head. And then when does this blue graph equal 1? It equals 1 right here when x is -2, here when x is 0, here when x is 4, and here when x is 6. Another one, the third and final one for solving an odd and even, was an odd and even question. This one. Is this graph odd? Is this even? Or is it neither? And here, even functions are symmetrical on the y-axis. And this one is not symmetrical on the y-axis, which means that, well, just visually it isn't, but it also means that if, for instance, this ordered pair 5, -1 is on here, if this were even, then -5, -1 would also be on there. If you switch the x values, you would have the same y value. That's what it means to be even. But graphically, if it's just symmetrical on the y-axis, it's even. So this is not symmetrical on the y-axis, so it is not even, nor is it odd, because to be odd, it has to be symmetrical through the origin. So like there's a mirror on the origin, and whatever's in the upper right will be reflected in the upper left. And this is not symmetrical about the origin. It's not really balanced on the origin. And the way ordered pairwise to tell is if you pick an ordered pair, any ordered pair, let's do 5, -1 again. If you switch the signs of both x and y, you should still be on the graph. So 5, -1, if I switch the signs, it becomes -5, +1. And -5, +1 is right here, but it is not on the graph. So this one is neither odd nor is it even, so it's neither. Okay, and then what's problem number 2? So those 3 resulted in the grade for odd, even, and solving. Number 2 was a piecewise function. So the second part of your grade was piecewise functions and transformations. So here I want to spend a little time here. F of 0. 0 is the domain, and 0 is less than 3. So we are using this part of the function. So it is -0 minus 2 squared. And I'm showing my work. Minus 3. That equals, a lot of people forgot this negative sign right here, which is so, that really hurts. It just, that little mistake, especially on the SAT is multiple choice. So little mistakes like that, you might as well have done the whole thing wrong. Just one little mistake like that. So you really have to be careful. That negative is outside of the parentheses. So you square -2, that gives you +4. But the negative, remember, is outside of the parentheses. So now that's really -4. And -4 minus 3 is -7. Full credit, you should get -7. And here's the work that supports it. The next one is f of 10, and 10 is not less than 3. 10 doesn't equal 3. 10 is greater than 3. So you're using this piece of the function. So 5 times 10 minus 21 equals 50 minus 21, which equals +29. Full credit, full stop. The third one is f of -3. Well, -3 is less than 3. So we're again using that top one. So negative, parentheses, -3 minus 2, square this, and then minus 3. So that's plugging it in, and then I evaluate. So don't forget about that negative outside, which some people did. You've got a -5. The -5 is being squared. Well, -5 squared is 25, but there's a negative on the outside. So +25 times -1 is -25, so it should have resulted in -28. This is for a different part of your test, a different grade. I want to do the parts that are all piecewise and transformations. This one is transformations. So this belongs to the same grade as the piecewise function part did. So you got a function, f of x. We have no idea what it is, but besides the fact that it's a function, and f of -10 equals 3. So that means there's an ordered pair, -10, 3. Now, where does -10, 3 get mapped to with these transformations? You have to tell me the ordered pair that it gets mapped to, and you have to describe the transformations. So first of all, some people described the transformations perfectly, and then just didn't map it correctly. F of x plus 40 means left 40. Negative 2fx, negative 2 times fx means a vertical stretch of 2 and flip upside down or flip over the x-axis. So the negative 2 did two things. And then finally, the plus 2 moves it up 2. And the order of operations here matters. We want to do multiplication before we do addition and subtraction. And you can work independently of x and y. You don't have to do x first or y first because they're totally independent of each other. So let's do this. I've got negative 10 comma 3. Well, if I move that to the left 40, then negative 10 becomes negative 50, doesn't it? Some people added 40 because they see plus 40 right here and they got positive 30. Even though they wrote left 40, they didn't move negative 10 to the left 40. If you're at negative 10, you're already to the left 10 spaces. And if you move left 40 more, you're at negative 50. And then the y value, remember plus or minus would come last with the y value. So I'm going to multiply by negative 2 first. So negative 50 just stays the same. Negative 50 is the x value. The 3 gets flipped upside down, so it would become negative 3. But then it also gets doubled because of that 2. So these two ordered pairs account for the negative and the 2 right here. And then lastly, up 2. Well, if you're down 6 and you go up 2, you've crawled all the way up to negative 4. So the final answer was negative 50, negative 4, with a description of what those transformations do. This also was for piecewise functions and transformations. So this was literally both of them. You had to know transformations to create this, and you had to know what a piecewise function is to create this function. So let's see here. I saw someone was pretty clever, and they put f of x in the middle there, and then they went back up to the top. Whoops. So first of all, the parabola. This parabola has a vertex of negative 3, negative 4. So it went to the left 3. So that's x plus 3. Squared makes it a parabola. Minus 4 brings it down 4. So your vertex is at negative 3, negative 4. But there was a vertical stretch because from the vertex, if you go over 1, the normal stretch would just be going up 1, but this one goes up 2. So this has a vertical stretch of 2. So outside the parentheses affects the y values. So 2 times 2 times the parentheses x plus 3 squared minus 4. And then now the domain part. Well, this parabola only exists between negative 5, including negative 5, and negative 2, but excluding negative 2. So negative 5 less than or equal to x, which is the same thing as saying x is greater than or equal to negative 5, but x also has to be less than negative 2, not less than or equal to. That's that piece. The second piece was the absolute value function, and this absolute value function is upside down, so right away I've got a negative. And there was no vertical stretch because from this vertex, if I go over 1, I go down 1, over 1, down 1. So just a normal stretch. I don't have to put a 2 in front or a 3 or something. But it did go to the right 2, so x minus 2, and it did go up 3. So there it is. And then now the domain, this domain begins at negative 2. So x is greater than or equal to negative 2, but at the same time less than 7 is the open dot right here. And I believe that was, oh no, this one as well. Okay, this is transformations again. This again contributed to the score for piecewise functions and transformations. Here, this is f of x. And which of these 4 options is f of 2x plus 1? Well, the 2 is affecting the x only, The +1 is affecting the y only. So only two transformations, one for the x and one for the y. You can look at your answers and you can automatically eliminate this first choice right here because this y value is -3 and it got pushed up to -0.5. So it went up 2.5. Well, that can't be correct because I know my y value only went up 1. So it cannot be that. This y value went down 2. So that just takes it out of the running completely. My y value went up 1. This y value went up 1, and so did this y value. So narrowing it down to these two gives you a 50-50 shot. Now the x values. What does this 2 do? Well, just like, remember the previous example, x -2 moved it to the right 2. That might be counterintuitive. You might think x -2 means move it to the left 2, but it means move it to the right 2. This, we would divide by this number. So you take all the x values and you divide them by 2. So this is a horizontal shrink. It makes it skinnier. And it is this choice, but let me explain why. This ordered pair, for instance, is 2, 1. The 2 is the x part. If you divide 2 by 2, you get 1. So now this ordered pair would become 1, 1. And then remember, the y value goes up 1. And so if you go up 1, there you are. You are right on this red dashed line. Again, it works for this. -4. This ordered pair is -4, 0. The x is -4. The y is 0. So if you take that -4 and divide it by 2, it becomes -2 and -2, 0. And then you move it up 1, it becomes -2, 1. This solution right here is 1/2 x and then +1. It takes all the x values and it divides them by a half, which is the same thing as multiplying it by 2. And that was it. The final grade, which was, I think, the most challenging one, is the first grade on Infinite Campus, I believe. It's on domain and range and also operations on functions. And that's the remainder of the test. This example right here, create a function that has this domain. Now, what is this domain saying? This domain covers all numbers except for -2. All numbers except -2. And some people were trying to give me a square root. Well, the square root of x plus 2 has a domain from -2 to infinity. That's it. This has a much bigger domain. It includes a ton of negatives and tons of positives. In fact, it includes every number except for -2. So square root function will not work. This is very simply, let's see here. Whoops. 1 divided by x plus 2 would be one acceptable answer. Think about this function, 1 divided by x plus 2. When you're finding the domain, there's two major guidelines. You cannot divide by 0, and you cannot take the square root of a negative. Well, here the domain is everything except for -2. So just create a function where -2 would make you divide by 0. And here is one such function. Let's see here. 12 was a good domain problem. Find the domain of this. And, well, I saw, and it says show work. So I was very happy with people writing down that this has to be greater than or equal to 0. That's true. I would please write that down to convince me that you know what's going on. That's correct, because you can only take the square root of a number that's 0 or bigger. And then that factors into x minus 9, x minus 3. So that 2 has to be greater than or equal to 0. And here's where the algebra stops. You have a quadratic that's greater than 0. And here in class, I really urged you to think about this graph. You know what a parabola looks like, and you know the zeros. 3 and 9 are the zeros. So imagine you had this parabola, and it's going through the x-axis at +3 and +9. Now, when is that parabola greater than or equal to 0? That's your domain. Here it is on Desmos. Here's x minus 3, x minus 9. It's going to be a parabola going through 3 and 9. Now this I would hope that you would just kind of scratch it onto your notebook paper when you're working through the test. Now, when is this parabola greater than or equal to 0? Definitely not here. All these y values are under 0, less than 0, less than the x-axis. All of these y values are greater than 0. And when x is 3 and when x is 9, the y value actually equals 0. So your domain includes the x values that produce all of these on the left and all of these on the right. So your domain is negative infinity all the way to 3, including 3. And then skipping over all those numbers between 3 and 9, picking it up again at 9, and then going on to infinity. That's the domain. Find the domain in the range of this. The domain is the set of all x values. Well, this function begins at -7, and it includes -7. So bracket -7. And it goes all the way to -2, and it does not include -2. That is the answer that you need for full credit. Do not be distracted by this removable point right here. You may think some people tried to split it up, but I don't think they did it successfully. -3 looks like it's a problem. Well, okay, something weird is happening. When x is -3, there's a hole right here in the parabola, but -3 as an x value is picked up again right here. So when you think about what are all the x's in this function, -3 is in there. It's not where we thought it would be, right, which is right here, but it is in this function. It's just displaced. So that all the x values in this function are from -7 to 2, not including -2, but including -7. The range is from -4 to 5, including. Every y value between -4 and 5 is included. Obviously, -4 is included. It's right there. -2 is included twice. -2 is included right here and right here. 0 is included. There's 0 as a y value. 1 is included, not here, but 1 is included here. In fact, every y value between -4 and +5 is on this function. So therefore, that's the range. Even +4. +4 as a y value isn't here on the function, but it is here. So it's part of the range. This is the correct answer for domain and range. Yes, this one is an operation. So we've got two functions, f and g, and we had to find f minus g. F minus g of 5 is the same thing as f of 5 minus g of 5. You are not distributing. It looks like you are, but you are not. This is just how operations with functions work. You take f of the domain, operation g of the domain. So f of 5 minus g of 5. Well, what is f of 5? F is the purple one. And here's when x is 5. And when x is 5, f produces 4. So 4 minus g of 5. Here's when x is 5. G produces -1. So I'm minusing -1. And remember what your past teachers told you: when you subtract a negative, that's the same thing as adding. So 5 is the correct answer. And again, I am just becoming more and more surprised that people are just giving me this answer without showing me the work, despite the warnings. So I hope that behavior is changing. You must show your work. When you're in doubt, just show your work. The second one is f divided by g of 0, which is f of 0 divided by g of 0. This is making me nervous. I hope g of 0 doesn't equal 0 because I can't divide by 0. Okay, f of 0. Here, when x is 0, f produces 2. And g of 0, when x is 0, g also produces 2. So this is really 2 divided by 2, which is 1. 3, f of g of 2, which if you got this one wrong, you may have multiplied. But this is not a multiplication symbol. This is a composition symbol. So you have to take 2, put it into g, see what that gives you, and then put that into f and see what that gives you. So g of 2, when x is 2, I'm right here, and g is the red one. G produces 0. So this is the same as f of 0, and we just talked about f of 0. F of 0 is 2. So the correct answer was 5, 1, 2. I love this problem. What is the domain of f divided by g? And explain how you got your answer. Tell me the answer in interval notation. Okay, f divided by g of x is f of x divided by g of x. So you need x values that are acceptable to f and at the same time acceptable to g. That's task number 1. Well, clearly 9, I hope it's clear that the number 9 cannot be in this division. I can't take f divided by g of 9 because f doesn't know what 9 is. 9 is not in the domain of f. It's in the domain of g, but not f. So I have to pick x values that are in both functions' domain. So that is from -4, they both have -4, and they have every number up to +8. So I begin with everything from -4 to +8. But I cannot divide by 0. So when does g of x equal 0? That should be a major concern for me because I'm dividing by g of x. Well, guess what? G of 2 equals 0 and g of 7 equals 0. According to my map here, when x is 2, g is 0. And when x is 7, g is 0. So that's a big problem. Not only does x have to be between -4 and 8, but x can't be 2 and x can't be 7 because that would make me divide by 0. So therefore, my domain is everything from -4 to 2, skip over 2, everything between 2 and 7, skip over 7, and then from 7 to 8. And if you got that, fantastic. But you need, of course, you need the correct answer with the explanation. 3 was another challenging one. Again, composition. Some people were multiplying, but this is composition. Find g of f of x. Okay, let's do that first. So g of f of x equals g of square root. If I use the symbols, you won't be able to see it. So I'm just going to write SQRT for square root of x plus 2. And what does g do, people? G squares what it receives and then subtracts 7. So it's going to square root of x plus 2. It's squaring that. And then it's going to minus 7. Well, if I square a square root, the square and the square root cancel each other out. So you are just left with x minus 5. X minus 5 is the correct composition of g of f. That's part of the problem. The other part is the domain. So here is the whole sequence of me doing the composition. Remember in class we talked about, I assume let x equal all real numbers. And then I see what happens. Well, what's happening to x first? X is going into f. And f has a problem. F cannot receive all real numbers. It can only receive numbers from -2 to infinity. And then, excuse me, and then as you continue, the square root disappears and you have x plus 2 minus 7. Nothing changes in your domain here because you're not taking the square root of anything new. You're not dividing. And then you're left with x minus 5. Again, you're not taking the square root of anything new and you're not dividing. So the final answer, with all the work supporting it, is x minus 5 with a domain of -2 to infinity. And that is the whole test.